So in this example, we'll learn how to discern and plot the various thermodynamic properties of a system. So we'll look at plotting the activity delta G, delta H, and delta S of the system. So let us start by creating the system first. So we'll go to equilib, we'll go here, new, clear the current system, and because you are inputting mg and si in the system over here, so we'll just keep the ft-lite database selected. So we have mg and si. This is 1 minus a. So we are adding more and more si in mg. So si is a. Uh, so we'll select the initial conditions because we want to calculate delta G, delta H, and delta S of the system. So for that, so to calculate the change in Gibbs energy or the change in enthalpy, we first need to specify the initial conditions in the system as well. So we'll go with liquid, liquid, and the initial temperature is 1600 degrees. So 1600 degrees. And both are the same screen, so 1600. And then we'll set the calculation conditions. So again, the calculation temperature is again 1600. A will now be from 0 to 1 to 0.01. We'll select pure solids and we'll select all solutions. So now we'll just calculate and then we'll plot the various thermodynamic properties of the system. So first we'll plot the activity. So go to plot, plot results, axis. On the y-axis, you can select activity. So this is the activity. On the x-axis, you actually want to select alpha. So which is the amount of SI we are adding in the system. Refresh, okay. And we are going to select activity or species in the liquid solution because that is the only solution that is forming in this case. So liquid number one. So Mg and Si, and we'll do okay, and then we'll plot. So this is the activity of magnesium in the system as the amount of Si in the system is changed, and this is the activity of silicon in the system as more and more silicon is added in the system. So now we'll close this and we'll now plot delta G of mixing versus the amount of Si or alpha. So we'll select delta G here, refresh, okay, and plot. So this is the delta G in the system. Then we can also see how to plot delta H. Again, go to plot delta H. Alpha remains the same. Refresh, okay, and then plot. And lastly, what you want. So we'll go to axis. We'll go to delta S. Again, refresh, okay, and plot. So this is the change in entropy of the system, delta S. So this is precisely what is shown in the next slide. So this is the activity and this is the delta G that I showed you previously. This is the delta H and this is the delta S. So now we are going to see how to plot the isoactivity lines in a ternary system. So from FACSIS 7.0 onwards, there is a very easy way to do that with the phase diagram module. There is also another way how we can plot the isoactivity lines, and that is using the equilibrium module. So we'll see how to plot isoactivity lines with both of these modules one by one. So let us start with the phase diagram module first. So I'll go to the phase diagram. And we are going to plot isoactivity lines for Mg, Si, Sn ternary system. So we are going to add Mg, Si, and Sn. The database that we're using for this calculation is ft-lite. We'll go next. And what we want to do is we want to select pure solids. We want to select all solutions. And what we also want to do is select pure liquids in this case. Then we'll right click on the liquids, and as you can see, you have three pure liquids. So Mg, Si, and Sn. And for the Mg liquid, what we are going to do is we are going to fix different values of activities in the plot. So what we'll do is we'll right click on the plus icon. We'll go to isobars, and from isobars, so we can enter up to 10 different iso activities for Mg liquid. So because 10 activities will take a lot of time to calculate, so I have added four different values over here: 0.8, 0.6, 0.4, and 0.2. Okay, and then okay. Since we are calculating at 1350 Kelvin, so I'm going to change my units over here from degree Celsius to Kelvin. Okay. And then we are going to set the calculation conditions. So we want to plot the triangular ternary phase diagram. The temperature is at 1350 Kelvin, and we just want to calculate the isoactivity lines at this temperature. So it's going to be an isothermal projection. At A corner we have Mg. At B corner we have uh, s- silicon. So I'll go here 1 0, and at C corner we have 10. So this, and now I'm going to calculate the ternary diagram. So as you can see that Faxit is now calculating the isoactivity lines. So this is probably 0.8, this will be 0.6. Now Faxit labels and masses. So these are the different isoactivity lines that we ask the software to plot. So now we'll look at calculating the isoactivity line in a ternary system with the equilibrium module. So the first thing that we are going to do is we are going to go to the equilibrium module, and we are going to input our system. So the database that we're going to select is FT-Lite, and we'll clear the system. Yes, yes, initial conditions you can remove, and then we have MG, SI, and SN. So what we want to do is first we'll change the units from grams to moles, and now what we want to do is we want to scan the ternary phase diagram for a particular composition of Mg. So like in this example, we are scanning at Mg is equal to 0.3. So we are scanning the ternary diagram from left to right. So Mg is equal to 0.3 will be constant. We'll be changing SI and SN. So if SI is A, then SN is going to be 0.7 minus A, because the total system is 1 mole. Then we'll just go next. And again, what we'll do is we'll select all the solutions. We'll select pure liquids. We'll select pure solids, and we'll also select pure liquids. And then we'll again right click on pure liquids. We'll again right click on the plus sign for Mg liquid, and we'll go to activity. And here we'll click on activity, and we'll add one value of activity that we want to fix. So over here, let's say that we're fixing the activity of Mg at 0.1. We're going to go OK. Okay, and then we are going to set the rest of the calculation conditions. So A belongs from 0 to 0.7. Let's take the interval 0.01, and the temperature of calculation is 1350 Kelvin. So I'll go to units again. I'll change from degree Celsius to degree Kelvin. Okay, select all solutions and calculate. So now after our calculation in for equilibrium is done, what we're going to do is we're going to print a spreadsheet. So let's print an open text spreadsheet. We are going to go to spreadsheet setup, and what we actually want to do is we want to print the composition of the liquid. So we have alpha over here. We have X, which is the composition over here. So alpha is nothing but the amount of Si that is added in the system. And over here, what we'll do is we'll select the species. So in the species, we'll go to this Mg liquid. So this is FT light liquid number 1. So we'll have two liquids over here. First is the pure liquid, and the second is the liquid solution, FT light liquid. So we want to select the liquid solution over here. So we'll have Mg liquid, we'll have Si liquid, and we'll have Sn liquid. So we'll select these properties, and then we'll go OK, and then we'll print out this spreadsheet. So what this actually shows is when we add different amount of SI, And when we fix the activity of Mg at 0.1, what is the composition of liquid? So because liquid was because we did our calculation by selecting the I option for the liquid, we have both liquid number one and liquid number two. But as you can see in the results window, that liquid number two is actually 0 grams. So even at different composition of Si, liquid number two doesn't form. So we are only concerned with liquid number one. So what I'll do is that I'll just select all these and I'll copy them. So Control C, and I have an Excel file over here, and I'll just paste all of that over here. So you can also directly save it in an Excel file if you want. I'm just doing that because I feel more comfortable this way. And now what we'll do is we'll plot all of this in a triangular phase diagram. So for that, we'll go to fact stage, we'll go to figure, and we'll go add and a ternary frame. And we'll go OK, OK, and we'll go to our Excel file and we'll select all these three compositions together. So, so just Control C and Control V, and we'll go line, okay, and okay. So this is the isoactivity line in the MgSISN system for activity of Mg to be fixed at 0.1. So as you can see, so let's close this. So as you can see, even over here, so this is exactly what we are doing over here. So here we are directly saving from, so instead of opening our in an open text spreadsheet, we are directly saving it in an Excel spreadsheet. So you can also do that. And this is exactly what we plotted, the isoactivity line of Mg at 0.1. So